Hello everyone. So today we are talking about the next gas law, and that is Gay-Lussac's law. So this goal is I can solve problems that involve the pressure and temperature of gases. So here we're just talking about temperature and pressure, so let's see what happens. Here our temperature is increasing, so it's going up. Our pressure is also increasing, which is why the chart, as the pressure goes up, the temperature also goes up. With this information, we can get to the definition of Gay-Lussac's law, which says the pressure and absolute temperature, or Kelvin, of a gas are directly related, which means if the pressure goes up, temperature goes up. If the pressure goes down, temperature goes down. That is why if you have a balloon and you take it outside and it's really cold outside, that balloon is going to shrink because that pressure inside is lesser, so then it makes it shrink in, which gives us the formula P1 over T1 equals P2 over T2. So this is very similar to the one we did in the last video, only we're talking about pressure instead of volume. So let's do an example together. Let's see. If I have a pressure of 2 atm and a temperature of 200 Kelvin and change the temperature to 0 degrees Celsius, what is my new pressure? So go ahead and write that example down as well. So first thing, let's just put what we know. If I have a pressure of 2 atm, so we know our first pressure is 2 atm, and a temperature of 200 K, so our first temperature is 200. It's already in K, so we don't need to do anything to that. And then we change the temperature, so our second temperature is 0 degrees Celsius, but we need to change that to Kelvin. So we go back to our formula, which I have it up here as well. Kelvin equals Celsius plus 273. So you will need to do 0 plus 273, which is just 273. And then what is my new pressure? So we are looking for P2. So let's plug that into the formula. We have P1 over T1. So let me see something real quick. Make that small. Okay. So our P1, oh, it's not going to let us edit it. Oh, well, I tried. It'll just have to be the makeshift fractions. So P1 is first, so we have 2 divided by T1, which is 200. Equals our P2, which we don't know, so X divided by our T2, which is 273 Kelvin. So remember, just like earlier or with Charles' law, we cross multiplied. It makes our math just a little bit easier. So you will do 2 times 273 equals 200 times X. So if we do that, we get 200X equals try to make it look nice for you all. Oh no. Come on. 200x equals, and then we'll do 2 times 273. 2 times 273, 546. 546. Now we need to get x by itself, so we'll divide 200 since it's being multiplied. So divide by 200, and then you'll do the same on this side. Divide by 200. That'll give you x by itself. So 546 divided by 200. That is 2.73, so we can put 2.7, and we found pressure. The unit for pressure is ATM. So in your digital notebook, you have 3 problems for this. I do have the formulas up top for you. If you need questions or need help checking these problems, let me know, and I'll be happy to help.